components of a vector. So, so how would we determine, kanina, I introduced this, AZ, AX, and AY, but how should we exactly, how can we calculate these quantities given angle theta? By the way, theta is not always theta there. It's just a label. Right now in our tutorial or even in our module, I use a symbol theta. Okay, but pwede man po na gamiton ako omega. Basta ang akong ginamin when I say theta here in this particular context is that the angle measured from z-axis towards the vector. Okay. So how could we determine the components? So I guess we have to use now your trigonometry. So again, balik na drawing sa atong vector. Okay. You have y-axis, x-axis, z-axis. Let's say you have a displacement vector, and let's call that as d. Okay? Let's have a displacement vector d. By the way, vectors are only defined based on their direction and magnitude. It doesn't mean na lagi kang mag-write dito sa origin, ha? Pwede na siyang, it's being translated somewhere. You can write it here as long as the same direction and the same length ang kataas ng vector. When I say kataas, the length of the arrow, that is magnitude. Okay, so given the angle, again, so it has its direction here. You have your D along XY. Okay, and then here it should be parallel with this axis. Then here. So this is your dy, dx, and dz. Okay. Again, we know the important is you should know the angle. Okay, you could not proceed later with the calculations if you have no sufficient information. So in this case, let's have an angle theta. So tawagin natin angle theta. And then you have another angle here from x-axis towards the vector, and I'll call that as angle phi or angle phi. So how could we determine the components? How would we know the x? Let's start with dz. What is the magnitude of dz? Okay, how would we know it? So basically, once you know the magnitude of d sub z is basically d cosine theta. Y, okay, y. Focus here. This also forms a triangle. This is the hypotenuse. This is the angle, so this must be the adjacent. And this is the opposite. If you can still remember, one mnemonic device that we use sa relationship, if you have a right triangle, is we have this. So, S for sine theta for whatever angle is opposite over hypotenuse. However, our concern is dz. In this case, it's the adjacent, and we have a value for the hypotenuse. So sine, as I said, is opposite over hypotenuse. It's not useful. Cosine is adjacent over hypotenuse, and we want to deal with adjacent. So adjacent, so if you have a triangle, review. If you have a right triangle, okay, if you have, again, right triangle, and you have an angle, let's say it's called theta, and this is your hypotenuse. This is your, of course, automatic sa kilid ng angle is adjacent. Opposite side of the angle is opposite. So, ka, towa. It means you can calculate for sine theta is opposite side divide hypotenuse. Or, if your concern is opposite, it means height multiplied to sine theta, that's opposite. So for cosine, cosine theta is adjacent over hypotenuse side. And then you could use this, what I did, so that you could determine the adjacent. For TOA, tangent theta is opposite over adjacent. Opposite over adjacent. Opposite side over adjacent side. So going back to our concern here, our concern, since we have this triangle, this particular triangle here, this one, this is a right triangle, okay? It's a right triangle. Now, this side, if this is the angle, this must be the opposite. This must be the adjacent. And that's your hypotenuse side. And our concern is to determine dz, which is the adjacent, and what we could use, and the value we have so far is just adjacent and hypotenuse. So we should use ka, or cosine theta. And deriving that, we could calculate for dz as d, which is hypotenuse, times cosine theta. It starts it with like this. Cosine theta is adjacent, which is dz, over hypotenuse, which is just the length of d. And to solve for dz, it's just d cosine theta, which is that. To calculate for dz, we mentioned it's d cosine theta. So what we have here is basically we have a polar coordinates value, and then we could go to Cartesian. So to calculate for d sub x, it is, okay. Now this is kind of tricky. Dx and dy. Let's go back. Dx is basically the cosine of dxy. Okay? And dy is just the sine, the product of sine phi dxy. So let me write that. Dx is dxy cosine phi. But what is dxy? We have no direct value for dxy yet. As you can see, on the other hand, d sub y is just dxy sine phi. But what is dxy? As you can see, dxy, this one. Here, it's just a projection of d along this plane, xy. Para bang ganito? If you have a flashlight here coming from this direction, it will form this, if this is a beam of something, it will form a shadow here at this length. In that case, that is basically the sine of d. dxy is equal to this one here. D sine of theta phi, sorry. This is dxy. On the other hand, our d sub y is again d projection of d along xy, so that's d sine theta sine phi. That's it. So that's for dz, this dx, and for d sub y. So from there, we could plot the vector given the length along x, along y, and along z. If you notice, if the theta is equal to 90 degrees, it means that there's no projection along z-axis. If theta equals 90 degrees, what do you think will happen to dz? Then d cosine 90 degrees is what? What is cosine 90? Cosine 90 is basically 0. And as you can see, dx, which is d sine theta, let's see, d sine and 90, whatever the value of angle phi, sine 90 degrees, 1. So this is just 1. D sub x is just d cosine phi. And your dy would just be d sine phi. But I have to give warning ha, kay basig maka-encounter mo in the future, pag nailibro nag-mention of theta, inyong imagine na ang theta is always here. You always go back to the illustration, to the diagram.